This is my circuit displaying a screensaver on the 3.2-inch TFT LCD. I'm using the memory card, the SD memory card. It holds the file as a bitmap, and I use that same bitmap in two positions, and they mirror each other. The 3.2-inch LCD, it operates on 3.3 volts, and so that's why we have from the Arduino MEGA over here, we have all of these guys right here. I'll get a better view. Pins 22 through 41. Not all of them, but the 16 of them go through the resistors, these 10k ohm resistors, then from here to the LCD. Be nice if they're, especially for troubleshooting, if these rainbow ribbon connectors were the same colors. Unfortunately, I didn't have enough to match up all the colors. I like to have them grouped like this, though, 8 and 8 if possible. If not, then I had some that were kind of split, so I used those. But it makes it a lot easier for troubleshooting if the colors here are coordinated here. There's a power supply that I made out of a oven relay board, actually, and I converted it to, it's got a 21 volt DC output, and I converted, as you can see, to 3.3 volts, 5 volts, and 9 volts. It has a 3.3 volt output from the power supply. The 21 volt I actually convert using these two ICs, and try to get a close up here. There it is. That's a 7805 CT and 7809 CT. I know it's a little hard to see. I also just hooked up a fan for cooling, and I scrapped this heatsink from a washer control board that I replaced. So that's the circuit we're looking at, and so you can see there was one added one added feature here. I set up an LDR over here between A0 and ground, and so that will control the light on that resistor, will control the speed. As you can see, it's going a little slower, and now if I cover it up, now if I lift my hand, it goes faster. And if I actually shine a light on it, I'll get my light out, then it goes a lot faster. So that's the basic circuit. This is the circuit diagram. Just trying to think if there's. Sorry about that. Okay. This is the circuit on the left, the Arduino MEGA. As you can see, the 5 volts directly goes to the LCD directly. You can switch it if you want, but the problem with that is you're limited on the current that a Arduino pin output is going to have. This one just goes directly from the 5 volts directly to the LCD, so it'll get you more current that way. I haven't tried it using the other, but you only have like recommended 20 milliamps per pin if you go through a digital out pin from the MEGA. So I wasn't even going to do that because that's too little. I believe I clocked it at 180 milliamp, come to think of it. I believe that's what it was, 180 milliamps. when I took the just the 5-volt pin up. So that's way more than what the digital pins can supply. Anyways, these over here are the touchscreen pins. In this circuit, I did not use the touchscreen feature, but it's hooked up anyways, just for if I need to in the future. These are all the 10K resistors. If you count them up, it's between 16 total, and the RS, WR, CS, and rest pins do not have a resistor going to them. And let's see. This is important here. The ground, I have the ground of the LCD, an external power, which is also hooked up to the ground of the LCD and the Arduino, and then the 3.3 volts from my external power supply. Again, that is that one right there. Goes to the LCD VCC. I do not use the Mega 3.3 volt output. I've had problems with it working, and I believe that there's a lot of questions online why does my LCD screen not work. I just get a white screen, and that white screen is they got the 5 volts for the LED, just like you see there. And I'm gonna just demonstrate this real quickly. 3.3 volts in general is not recommended. Let's see. Okay, I'm gonna reset it. Still got it. It looks like I'm drawing enough juice from the computer this time, but I have had problems with running programs actually drawing bitmaps, or not bitmaps, I'm sorry, raw files that are going to be big enough to run on this 320 by 240 where they try to draw too much current and it won't run. But you can see there's a bit of flicker. If you can see that flicker in the screen, whereas I didn't have that before. And when I use, the best results I get are with my external power supply, which I'm not using right now. When I put this thing to 3.5 volts and I hook up the LCD, that's going to actually get me the cleanest picture without flicker that I can get. And so I believe a lot of the problem that people have in hooking up Arduino Uno or Mega to the LCD, or the LCD to these boards, is they just don't have enough current draw from the power sources, be it their computer or probably most of the computer, I'd say. But anyways, so that's the 3.3 external power source, and then this is the 4 pins for the SD. On the Mega, it's going to be these guys right here, 50 through 53, and that's pretty much sums that up. I'm going to show you the code that I hacked. Let's see here. So you can see I'm using the UTF-T Tiny Fat. That's for the SD card. So you can pretty much see what I'm doing here. I'm just creating and initializing, and down here this is for the LDR. So if it's certain resistance, which is converted to analog to digital, then it will, these are the amount of milliseconds that it will delay. So there's 0 delay if I shine a light on it, because the analog read register is less than 100. So anyways, let's see, then here we load the bitmap, or sorry, the raw file here, and you can see the locations I use. Invert X and invert Y, or sorry, location X, location Y, and invert X, invert Y. Basically, that's how I have two on the screen and two Roku logos on the screen, and then I just draw them at different different places on the screen, and they're inverted. The 7525, that's the size of the bitmap. Alright, and the last section here is basically they're conditional statements on the location of the X, invert X and location X. And so basically it's this is how it bounces off the side of the screen. Here, let me go ahead and, so it starts at the upper and bottom corners, and then it travels, and it just increments it by 5, the location, and redraws the bitmap. And then if I programmed it so that if it is equal to the edge of the edge of the screen, then basically change direction, and that's how I got it to bounce off of the sides and the top and bottom. So that's that code right there. That's pretty much it. Thanks for watching.